Welcome to Data Nutshell. In the previous videos, we saw how RAID 4 and RAID 5 use parity to protect against data loss. RAID 5 gave us protection from a single disk failure. But what happens if two disks fail at the same time? RAID 5 cannot recover from that. That's where RAID 6 comes in. RAID 6 is like an extension of RAID 5, but instead of one parity block per stripe, RAID 6 stores two different parity blocks. This means RAID 6 can survive the failure of any two disks in the array. So let's see how RAID 6 works. So the data is stripped across all disks, just like RAID 5. But instead of just parity P, RAID 6 also has a second parity Q. So every stripe looks like D1, D2, D3 up to Dn data blocks, then a parity P, then a parity Q. So the parity P is simple as we saw in RAID 5. It's simply the XOR of all data blocks in the stripe. Q is more advanced. It is calculated using Reed-Solomon codes. We don't have to go into the details of Reed-Solomon codes yet. So how is P calculated? P is computed as D1 XOR D2 XOR D3 up to Dn, where D represent data blocks on different disks. How is Q calculated? To calculate Q, we just multiply the data blocks with some constant values before taking the XOR. So Q is C1 D1 XOR C2 D2 XOR C3 D3 up to CNDN, where Ci is a constant multiplier. This constant multiplier will be different for all the disks, which ensures that Q is linearly independent from P, which gives us two linearly independent equations so that we can calculate two variables. So if we lose two disks and two data blocks, those two data blocks can be recomputed using those two equations. So P handles single parity while Q brings in the magic to handle the second loss. See how write works. Writing to RAID 6 is more expensive than RAID 5. Let's see why. Suppose we want to update a single data block, say DJ. J here represents the index of the disk that we have lost. So the first step will be to read the old values. What we will read? We will read the old value of DJ, old value of parity P, old value of parity Q. Then we will have to update the parities. What will be the updated value of parity P? It will be old value of parity P XOR old value of data block DJ XOR new value of data block DJ. How will we calculate the updated value of parity Q? New value of parity Q will be old value of parity Q XOR Cj times old value of data block DJ XOR Cj times new value of data block DJ, where Cj represents a constant that we associated with the disk on which data block DJ lied. So, what is the write penalty in RAID 6? As we saw, updating a single block required reading old data block, reading old parity P, reading old parity Q, writing the new data block, writing the new parity P, and writing the new parity Q. So, that is 6 input output operations per write. As compared to RAID 5 had 4 output operations per write. RAID 6 has 6 input output operations per write. That is why RAID 6 has a higher write penalty than RAID 5. What happens when disks fail? If first disk fails, recovery works just like RAID 5. We use the parity value to recover the missing data. If the second disk fails, now we have two unknowns. Say you have lost your second and fourth disk, so your data blocks D2 and D4 are gone. So you can calculate those two variables using the two equations that you have, because parity P is D1 XOR D2 XOR D3 up to Dn, and parity Q is C1 D1 XOR C2 D2 XOR C3 D3 up to Cn Dn. So you have two independent equations, two variables, those you can calculate. So this gives you backup for two lost disks. That's the power of RAID 6. So what are the strengths of RAID 6? The strength is that it can tolerate two simultaneous disk failures, which is great for large storage arrays where chances of double failures are high, and it gives a good balance of capacity and fault tolerance. What are the weaknesses? The weakness is the write penalty, which is high, 6 input output operations per write. It has complex parity maths, which requires more CPU usage compared to RAID 5. Rebuilds are slower because constructing two disks can take a long time, especially with multi terabyte drives, and as the parities also take more complex mathematical calculations, that also takes some extra time, and during rebuild the performance it suffers. So RAID 6 is essentially RAID 5 with an extra layer of prediction. By using both XOR parity and the Reed Solomon parity, it survives two disk failures. This makes RAID 6 ideal for large scale enterprise storage where data safety is critical, but the trade off is slower writes and longer rebuild times. So RAID 6 is strong and resilient, but it comes with some cost and performance. If you like the video, please hit like. Thank you so much.